Hello, welcome to the Tennessee at Home Learning Series for Math. Today is for all fifth graders out there, although other children are welcome to join in. This lesson is the 8th lesson in our series. My name is Miss Williamson and I'm a fifth grade teacher in Tennessee schools. I'm so excited to be your teacher today for this virtual lesson. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find it at the Tennessee Department of Education website or www.tn.gov/education. You can still tune in to today's lesson if you haven't seen the others, but it might be more fun if you first go back and watch our other lessons since we'll be talking about the things we've learned previously. Today, we'll be learning about subtracting with mixed numbers. Before we get started, to participate fully in this lesson, you will need paper, a pencil, and a surface to write on. I'll give you a moment to gather those things. Okay, let's begin. This warm-up is going to be important practice for us solving our problems today. Let's start by thinking about mixed numbers. What do you recall about mixed numbers? That's great. You know that mixed numbers are numbers that are composed of whole numbers and a proper fraction. Here is an example of a mixed number, 1 3/4. Write 1 3/4 on your paper. This is the number 1 3/4. We can make a visual model of this mixed number by drawing fraction bars. Let's do that together now. Are you ready? Great. Let's start by drawing a 1 fraction bar. Is that going to be enough? No, it's not, because we have 3/4 as well. So we're going to need another fraction bar. Our second fraction bar is going to need to be split into 4 pieces because our denominator is 4. Now, what would I need to shade in to represent 1 3/4? I need to shade in the whole 1 and 3 out of the 4. Make sure your model looks like this. Now, if I divided my whole into 4s as well, I could represent this a different way. I could say that this is, instead of 1 whole, I could say that this is 4/4. So if this is 4/4 and this is 3/4, how many fourths are shaded in all? I agree. There are 7/4. So I could say that 1 3/4 is equivalent to 7/4. Let's try another one. I want you to try to model the mixed number 1 5/8. How many fraction bars will we need? 2. How do you know? That's right, I see. We have a number bigger than 1, but smaller than 2. So we'll need 2 fraction bars. Let's draw those. 1, 2. All right. How will I need to cut up my fraction bars? Did I hear you say 8s because our denominator is 8? Well done. 1, 2, 3, 4, 5, 6, 7, 8. So we have 1 whole and 5/8. Now, what can I do to my whole to represent this in a different way? That's right, I could cut it into 8 because it's going to take 8 pieces to make the whole. Will you do that with me? 1, 2, 3, 4, 5, 6, 7, 8. So now, how many 8s are shaded here? That's right, there are 8 8s shaded here and 5/8 shaded here. for a total of how many? Yes, there are 13. So 1 and 5/8 is equivalent to 13 eighths. Great job warming up. Now, are we ready to do some subtraction problems with mixed numbers? I want you to think about a mixed number, but let's think through with a real problem. Are you ready? Follow along on the screen and read it with me. On Saturday, Chloe spent 3 1/4 hours at the park with her family. Then she spent 1 2/3 hours riding her bike. How much longer did Chloe spend at the park than riding her bike? Give your answer as a number of hours. So you'll notice that these are written in word form, well, partially. So let's go ahead and write those numbers down in fraction form. 3 1/4. So Chloe spent 3 1/4 hours at the park. Then she spent 1 2/3 hours with her bike, on her bike, riding her bike. How much longer did Chloe spend riding at the park than riding her bike? Now, I want you to go through and I want you to think about, what is this problem telling us? Excellent. It's telling us she spent this much time at the park and this much time riding her bike. I noticed that the times are given to us as mixed numbers. Recall, a mixed number is when you have a whole number and a proper fraction. So both times are greater than a whole. Do you agree? Fabulous. I also notice that these fractions do not have common denominators. Remember, we have to be able to have a common denominator or they don't have equal sized pieces. So that's important before we start our calculations to remember. So let's draw a visual of our first mixed number. Let's start by drawing 3 1/4. How many holes am I going to need? I'm going to need 4. 3 1/4 is bigger than 3, but smaller than 4. So let's start by doing our 4 fraction bars. You'll notice Miss Williamson tries to keep them as uniform or the same as possible, but sometimes it's a little harder to do. Now, if I want to model this, how many holes should be shaded in? That's right, 3. What do I want to do with my last one to represent 1/4? I want to cut it into fourths. How many should be shaded in? 1. Beautiful. So our model shows 3 1/4. Do you agree? Now let's model our other mixed number. Our other mixed number is 1 2/3. So how many fraction bars do you think I'll need for that number? 2. How did you know? Oh, because each one represents 1, and I know 1 2/3 is more than 1, but less than 2. Great suggestion. So we're going to do 2. How many holes should be shaded in this time? 1. What do I need to do with my part? Yes, I need to cut it into thirds. How many pieces should be shaded in? 2. 2 of the 3. Well done. So we've modeled 3 1/4 and 1 2/3. Now, let's think back to our problem. What was the problem asking us to find? I want you to follow along while I reread that problem. On Saturday, Chloe spent 3 1/4 hours at the park with her family. Then she spent 1 2/3 hours riding her bike. How much longer did Chloe spend at the park than riding her bike? So what does it want me to know? Oh, I heard somebody say it wants me to determine how much longer Chloe spent at the park than riding her bike. How do I figure that out? Yes, I agree. We're going to subtract because we're comparing the numbers and finding the differences. Now, the denominators of these mixed numbers are different. What can we do to help make subtraction easier? Oh, okay, we can find a common denominator to make equivalent fractions. Right now, our denominators are what? 4 and 3. So let's go back to thinking about our multiples. Go ahead and list the multiples of 4 and 3. Did you say 4, 8, 12, 16? And 3, 6, 9, 12? And so what common multiple sticks out to you? To me, 12 sticks out. I know that a multiple of 3 and 4 is 12. So I can get the common denominator of 12, which means I need to do what to my model? I need to represent them and not in fourths or not in thirds, but in twelfths. So how am I going to do that? Let's start with 3 and 1/4. What do I need to do to 3 and 1/4 to be able to make it into twelfths? Okay, I heard that 4 divided by 4 times 3 is 12. And so we can cut each of our sections into 3 to get 12 pieces. Let's try it. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. I want to check myself to make sure I have 12 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I want to do the same thing with the second fraction, but this time instead of cutting it into 3, what do you think each piece is going to need to be cut into? 12 divided by 3 equals 4. So each of my sections needs to be cut into 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Once again, I'm going to check 4, 8, 12. Fabulous. Fabulous. So we used the common denominator 12 and we divided our thirds and our fourths into 12 pieces. Now we have 3 and 1, 2, 3 twelfths, and we have 1 and 1, 2, 3, 4, and 4 is and 8 twelfths. What do you notice about 3 twelfths and 8 twelfths? That's right. When we go to subtract, because we want to know how much longer, 3 twelfths, I don't have enough. I don't have enough. So what do you think we need to do? We need to break apart another one of our mixed numbers. So instead of just breaking this one apart, I'm also going to break this one into how many pieces? That's right, into 12 equal pieces. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Fabulous work. So now that we broke them into the right number of pieces, can I solve? I can. What would the equation be for what we want to do? Excellent. I could say 3 and 3 twelfths minus 1 and 8 twelfths. But we already said that I can't do that because I only have 3. So we're going to rewrite this. Instead of 3 wholes, I'm now going to think of this as how many wholes? 2. And how many pieces? 12, 13, 14, 15 and 15 twelfths, minus 1 and 8 twelfths. Can I solve now? Yes, I can. I have enough pieces to take away. How many am I going to take away? I'm going to take away 8 from my 15. So this is what I have. I'm taking away one whole, exit out, and 8 twelfths. 1, 2, 3, 4, 5, 6, 7, 8. Leaves me with one whole and 1, 2, 3, 4, 5, 6, 7 twelfths. Now let's try another problem. Are you ready? I want you to write 4 and 3/5, 4 and 3/5 minus 9/10. I want you to start by drawing a model. Remember, start with this number. Did you draw something that looks like this? 4 holes and another one cut into fifths. How many should be shaded in? 4 holes and 3/5. What about 9/10? How did you model 9/10? Did it look something like this? One, two, three, four, 5, 6, 7, 8, 9, 10. And how many should be shaded in? Shout it out at me. Great, 9. Fabulous work. Now, do we have a common denominator? No, we don't. So what will the common denominator be? I heard you say tenths. How will we have to subdivide to get tenths? Yes, I heard that we're going to divide our 3/5 and split them in half to get tenths. So we could now say that 4 and 3/5 is equivalent to 4 and 6/10. Do you agree? Fabulous. Smart thinking. So we have 4 wholes and 6/10. Is there enough tenths to take away 9/10? You're right, there's not enough. So what can we do? Good thinking. We can break apart one of our wholes, another whole. This is called regrouping. So I'm going to take one of my wholes and I'm going to cut it into 10 pieces. Now I have how many tenths? 10, 11, 12, 13, 14, 15, 16. So now I could rewrite this fraction to say it is 3 and 16 tenths. Do you agree with that? Fabulous. And so 3, if I have 16 tenths, do I have enough now to take away 9? Yes, I do. I want to take away 9. So there's 6, 7, 8, 9, leaving me with a difference of what? Yes, 3 and 7/10. 1, 2, 3, 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10. So our difference is 3 and 7/10. Great work. Let's practice some more problems together. This time, I want you to try 2 and 1/4 minus 1 and 1/2. I want you to draw your model while I draw mine. Did you draw 2 holes and split your last one into fourths? I'm sorry, did you draw 3 holes and split your last one into fourths and shade in 2 and 1/4 for your first number? Did you shade in 1 hole and 1/2? Check your work. Now, my question to you is, can I remove 1/2 from my model? No, I don't have a common denominator. So what could I do to get a common denominator? I heard somebody say that 2, 4 was a multiple of 2. So I can cut my halves into fourths. So 1/2 is equivalent to 1 2/4. So now I'm going to ask you the question again. I have 2 1/4. Do I have enough to take away 2/4? No, I don't. So what do you think I need to do? Excellent. I heard somebody say I need to regroup. I'm going to need to use another whole and cut it into fourths. So let's do that. Now let's rewrite this fraction. Instead of 2 1/4, we could say it's equivalent to 1 5/4. Do you agree? Fabulous. And if I have 5/4, can I take away 2/4? I sure can. Remember, how do I model subtraction? Amazing work. Remember, we mark it out. We show it being removed. And so I need to take away 1 whole and 1/2/4, which leaves me with what? Did I hear you say 3/4? Great work. So I could say that 1 5/4 minus 1 2/4 is equal to 3/4. Our next problem is going to be 3 1/2 minus 2/3. What would you do first? That's right. We need to get our model ready. Can you model this and find a common multiple to split it into equal sized pieces? Great. You do your work while I do mine, and then we'll go over it together. Did you draw 4 rectangles, shade in 3 to represent the 3 holes, and then cut your last one in half and shade in 1 of the 2? Did you do 2/3, 2 out of the 3? How did you subdivide those? Did you find the common multiple 6 to get 6 equal pieces? You did? Fantastic job. Now, let's model the subtraction. What number are we subtracting? Well, you'll notice I have 4 6. So let's rewrite this. 3 3 6 and 4 6. Do I have enough 6 up here to take away? I don't. So what are we going to do? We're going to regroup. We're going to decompose a whole into 6 pieces. So let's do that. So now what is represented? 2 and 9, 6, minus 4, 6. Now do I have enough 6 to take away? I sure do. How did you model that? Excellent. You took away 4. So 1, 2, 3, 4, which left you with a difference of 1, 2, 2 wholes, and 1, 2, 3, 4, 5 out of 6. Fantastic. Think back about what we've learned today. When subtracting the mixed numbers 2 and 3/12 minus 1 and 1/12, do you think we would have to regroup? That is 2 and 3/12 minus 1 and 1/12. Do you think we would have to regroup? You're right. We wouldn't need to regroup because we have enough 12s to be able to take away 1/12. What about if we were subtracting 2 and 3/12 minus 1 and 8/12? Would we have to regroup? Yes, we would. We would have to regroup. We have 3/12. We do not have enough to take away 8/12. We would need one of the wholes, and we would need to change those into 12ths, which would give us 15/12. Great work, everyone. Today, we practiced subtracting with mixed numbers. I hope you're feeling confident about solving problems with subtraction and regrouping mixed numbers. You sure did a great job. I will show you the independent practice problems now, or you can find them at www.tn.gov/education. Here are today's independent practice problems. Zoom in so you can see a little bit better. Good luck, and I know you'll do your best. I've really enjoyed learning with you today about subtracting mixed numbers. Thank you for inviting me into your home. I look forward to seeing you on our next lesson in the Tennessee at Home Learning Series. Bye.